All right, so welcome everybody to another Open Game Data Open Office Hours. So just an introduction. So the Open Game Data community is an NSF-funded research incubator, bringing together a collective of researchers interested in the use of data generated in and around games to advance our scientific understanding of thinking, learning, and decision-making. And we have two primary goals in this group. One is to sort of collect a set of best practices and resources that advance the practice of how we use data to do this kind of stuff, and that's what these sorts of sessions are around. And then long-term, our goal is to build a actual concrete research infrastructure that instantiates a lot of these best practices into things that people can reuse and leverage. We have a bunch of resources that already exist. So there's the Open Game Data website that hosted by Field Day. We have a Slack group where we coordinate and share resources and ideas. And then we have these open office hour sessions, like the one today, that provide sort of this set of working examples of how we use game data. And we record them and put them up online. So how these sessions work, they're inspired by a series of sessions that the Statistical Education Research Group used to do here at Carnegie Mellon, where a student, typically, or sometimes a postdoc, would go to a member of the stats faculty and talk about a project they were working on. Often it was their thesis or something like that. And they would just sort of publicly workshop with a member of the stats faculty and just kind of talk about, like, have you thought about this? Maybe this, show me your code. Like, it was very interactive. It was very, like, essentially you were just going to office hours, but it was public and you could sit in the room and you can kind of see how do experts work through these problems. And it was super valuable to be there as someone looking to learn. So some things to keep in mind: presenters, when we have formal presenters here, they're often showing work that's in progress publicly. So keep in mind that that can take courage and be considerate of that. Our goal is to help the presenter understand and achieve their own goals. But also these sessions are about learning for everybody involved. So if somebody brings up something you've never heard of, or mentions a concept that you need clarification on, feel free to raise the hand. Or if you have something that a suggestion or from your own perspective, you can also do that as well. And with that, we will hand off to Dave. Is the one I put on the list for the presenter today, but I don't know how you guys want to handle things.
Great. Yeah. So yeah, sometimes, these are a little more formal. This is going to be a really good example of, like, let's get some smart people in the room and workshop an idea that we are trying to figure out. I'm not going to do slides or anything, but I've presented on our first iteration of Replay. And just to kind of name some goals and like challenges, what we want to get done today. And it might not all happen today, but what we want to start today is that we collaboratively have been developing some VR games and simulations that are part of a larger research project. And we have found that playtesting in VR is particularly problematic. Like, playtesting is always hard because you have to coordinate, get a group, you've got to like figure out some way to like learn from it. So you've got to usually have human, like researchers in the room. And even looking over shoulders and doing interviews with kids is like time consuming and costly and all that. So in the desktop game world, we've been using telemetry for a while now to try to augment what we can do in a classroom playtest. And that works well enough. But in VR, it's particularly terrible because even if you get a group of kids together, even if you've got a handful of staff and a handful of devices, so you've done all the work, you've got all the equipment in the room, you can't see what they see. Casting is super intermittent, and getting more than one cast working in a given Wi-Fi at the same time is even more intermittent than just one. So you've got this real bottleneck around seeing how people interact with your software. It's just really time consuming and costly, and it's really hard to do. So somewhere in the mix a year-ish ago, we were working on Waddle, the penguin game, and had the kind of the clever idea somewhere between Kevin and Eric and just, I don't know, just all the people I'm around. We're like, hey, what if we just send telemetry directly off the camera object and the hands object? And actually with penguins, the camera object is kind of the most important part because you waddle, you move your head. I realized my camera froze. So we can just send that, right? And then the second part of it was, if we take that and just hook it back into the input system of the game project, if we just route the same signals right back in, will it work? and surprisingly, it worked pretty great right out of the gate. I think we were sending 20 frames a second, approximately, 6 degrees of freedom, for the head, routed it back in. Kevin wrote some cool little code. It's a Unity module that you can easily enable. And it worked. And the next problem we ran into was that there were some parts of the simulation that were randomly generated. And we noticed that they weren't, performing right. So again, another quick hack was like, hey, let's send the random seed along with the first event. And sure enough, you replay it and random is not random. It's quite orderly. So everything is simulated exactly the way that it played out, and it works great. Okay, so there's a couple problems with this method. One of them is that it's obviously tied to a very fragile, reproducible, deterministic simulation. So it's just really fragile the way that's working in our current simulation. So that's a problem. The other problem is that you have to simulate everything in real time. So for physics and stuff to play out, the time steps have to be equivalent to when they were created. So the best way to do that is so far for us has been to basically run the simulation in 1 second equals 1 second and generate a movie file from it. And then we look at that video file. So it's been very useful. We already used it to identify some usability stuff, and yeah, it's got a lot of advantages having replay. But we need to go the next round with our new projects. For better or worse, they run on multiple threads. So now we've got all kinds of operating system lags and changes where one thread might not be on the same kind of clock as some of the others. And those mistakes, even if they're one frame, are going to start to add up over time. They're going to amplify over time. So that ends up being a real problem. And then the other problem is that there's no kind of like ground truthing that's happening in it. It's like we're getting the signals for the player, and we're getting telemetry, from the environment, but we're not getting anything about how anything's being simulated in the environment, or we're sending events of like, where was that object at this time, just to kind of make sure we're there. And then the other thing is, obviously it'd be really great if we could come up with a way to do replay that right out of the gate, it could have a time slider. So we can expand and compress time and do research with it. Okay, so I pull this group together, kind of a working group, because Ross and Autumn, who's going to join, are the engineers on the project. And Kevin's already built one of these things, and Eric literally has a PhD in replay. That was your dissertation. So what I'd like to try to do is think very practically for the upcoming, we call it the penny cook game. It's a research simulation. I'll explain here. How can we get a more robust replay system up and running? Like, what would be the technical steps? But toward a general purpose VR replay system that requires the least amount of coding for people to implement for future projects. So that's kind of prompt. Does that
Yeah,
sound about right?
can I ask a couple clarifying
Yeah.
questions, David?
Yeah.
So when you talk about a slider, are you thinking that it is a slider where you can slide this, you have your Unity window, you can slide the state and it would actually snap everything into the 3D state of the world at that point?
Yep. That's exactly right.
Yep.
And it's because the next round of this, obviously, is that we would make a web-based tool probably that would allow you to move the camera. It would allow you to add a second camera. It would allow you to like enable like any snapshot of any state variables that are happening, and basically build like your own little window into the simulation, and then be able to move time, turn off and on layers. Just imagine this thing where you're like, I want to know everything about what happened in this environment.
Mm-hmm.
And then I want to be able to annotate it. So we want to be able to scrub through that thing and mark moments of interest, or mark regions of the screen, or objects of interest. Because we want to eventually have something where, we're using it for usability. That's still our goal right now. Does this thing work the way we think it's working? But even there, in our first paper, you made those great observations. You're like, hey, here's 3 usability problems. As soon as you look at the video files, you see problems, right? And you look at the video files, you're like, oh, they're trying to pick up 2 rocks at a time, and they can only pick up 1 rock the way we built this thing, and they just don't understand it. And we were able to say, hey, let's go write a feature, or I'm sorry, let's go write a new log event and then roll that out. And now we can detect it, whenever it happened, but we weren't looking for it before. And obviously where we want to get is don't have to change the game. Via replay itself, we can use AI to create some sort of feature or some sort of detector just by pointing at stuff on the screen and say stuff like this, and
Mhm.
have it go look at the logs and feedback every example of stuff like this with just minimal training. Like that's the long game, I think, for us. And then obviously you're thinking stuff like this and how does it correlate or predict other features, and we're kind of off to the races once we can have a solid replay system that has access to all the state variables, including generating new log events we didn't have at the time. So, which is another kind of cool advantage. Like we log certain things, but we can absolutely play it back and then log new things based on the old logs if we can simulate it properly. So that's kind of the goal of it all, I guess.
Right. So I mean, it's interesting because so the similar issue that we have in our world is if you want to have multiple computers all simulate the same thing simultaneously for a cave environment,
Yeah.
it's the exact same problem, right?
Yep. I think so.
So the tricky thing, so the nice part is if we have the state of every object at every point in time, right, you can do that scrubber.
Yep.
This means we need to now somehow have the information of everything at every, or it's not every point in time, right? It's a fixed interval.
Yeah.
And so
a lot of points.
A lot of points, right? And so you would imagine that the inspiration is to take off of video compression, which you have what's called iframes and p-frames.
That's right where my brain's heading right now.
Yep. So the question now is, how do you figure out what is a good iframe and what's a p-frame? And then secondly, if you imagine in a video, right, you have a fixed, the number of pixels you have. The number of pixels you have in a video doesn't change.
Yep.
So do we have the same idea of here is every single object that we need to track? And is every single object that we need to track just every game object in the Unity hierarchy? Or does someone label them? If someone labels them, then you got to label them, right? Like that's somebody's job now.
Yep. And every object, the idea of every object at every moment is obviously just a lot of data.
It's a lot of data. That's what I was gonna say, right? So what we've already seen from the telemetry data is that a lot of the standard approaches already start to kind of be like, this is too much data. You need to kind of break this down into features.
Yep.
And so now the amount of data we're going to have is going to be
100 times that, let's say.
100 times that. Exactly.
Yeah. Objects.
Yeah.
And so far, clear text, JSON, 6 degree of freedom, floating point numbers kind of works when you've got 3 objects. It's like, we kind of have joked, it's like the same size as like a very small JPEG image.
Yes.
But yeah, I think the assumption here is we're going to run into data problems now if we tried that same approach with just 100 objects.
Yeah.
I can give you some insight about how I built my replay system. It also had a physics simulation problem. So it's towers of blocks, and we literally we moved the rigid body of the ground to make an earthquake, and that was how the feedback was determined in the game. I tracked every block, X, Y, rotation, velocity, and angular velocity. Ended up not really needing angular velocity, but it was in there. It was in 2D, so I at least dropped the dimensions I didn't need. And I don't think there was ever more than like 16, 17 blocks in a scene. The thing that I did coming out of a tutor mindset was I wasn't recording at a time clip. I was recording on user action. So it's mostly pick up and place. And so I would snap the whole state every user action.
Oh, wow, okay.
And then the convenient thing about that is I could jump into literally any action, construct its context, fire it, let it simulate forward, and see what was going to happen. And so a lot of what I was doing to evaluate like the stability of a tower is I would actually let time simulate forward past when the actual next action happened to see what would have happened if they'd stopped there. And I found using Unity on a laptop, you can actually crank timescale and you don't have a lot of drift. Like you don't get a lot of compounding error. And I could check it because I literally had a keyframe. I could be like, I would instantiate state, fire in action, go forward, and I could actually check against the actual state I had on file. And
Yeah, the next action you could like see if you got to the same spot.
and for a given small enough increment, and this was like literally rigid bodies bouncing against each other. There wasn't that much drift in terms like interpolation error. Cranking time speed up to like 5 or 10 in Unity. And that worked all right. But the bigger thing that I got out of that really is I stopped. I did the interpolation thing for a bit, but I eventually threw that out and just like I just have all the states. I'm just gonna grab the state that I want rather than interpolate up to the state I need. And so having that ability to infinitely index was really, really useful. In terms of generating features, another thing my replayer did, which I would maybe re-architect with more experience with Unity, but essentially what would happen is you would instantiate the state, you would fire the action, you'd run for some stopping condition. So either the amount of time until the next action or X number of in-game seconds, or you'd stop immediately. I think you could put a custom callback function. And then it would halt the engine and call an interpreter script that essentially just had free reign of the Unity state to calculate whatever the fuck it wanted and spit it out. So there was essentially like a callback where the whole engine would stop and you could calculate and generate a feature using the full suite of everything within Unity's libraries rather than trying to figure out how to do like box casting and rigid body calculations in Python. Like I don't need to fully reinstantiate box 3D or whatever. All that stuff's already in Unity. Why replicate it? And you can do things like I would often the background elements of the scene weren't relevant for me, so I would just replace them with a giant magenta screen, and I could cut that out in post. And so you can turn off renderers if you're generating screenshots. So I did a bunch of that. Mainly because I was sick of looking at the same thing all the time. And my replayer was built 100% to not be human watched. It was meant to be a thing that would generate data.
Yeah.
Which is always funny when I would talk to like Elizabeth at Turk and be like, oh yeah, and it's like, and you watch this? It's like, no, I just have the video to convey the idea of what it's doing. I never actually watched the thing. I like put it off to the side
10 years just watching
and
people
minimize the video.
building whole theories of how the mind works.
Yeah, and kind of being surprised that it's like, oh yeah, everybody wants replay so they can look at it. Huh. Yeah. So that's how mine worked. And I found, at least within Unity physics, it worked all right. I never had to deal with multi-threading or anything like that.
So you just took a lot of full state snapshots that happened to be timed right with the player action.
Yep.
The context of player action. And the whole state, you were encoding the entire state of the simulation in some way.
Yeah. And that was always custom written. I eventually had I think I eventually like wrote like a formalized abstract class of like replay recordable or whatever.
Yeah, exactly.
And I could see like you could like decorate a class or something. I think transforms is really easy. Rigid bodies is really easy. Like there's formalism of what you would want to capture.
Yeah.
And then also what do you need? So for example, if collider dimensions never change, you don't need to capture the collider. But like transforms are going to change a lot. You probably know that. You probably don't change scale. Maybe you do. So like you could probably cut pieces of Unity objects out that you know you're not going to need. And maybe you could figure out a way to do that intelligently, as like you were talking about finding the right frames, kind of a compression strategy. But certain things you could probably know off the cuff. But I would probably get position and velocity for anything they're trying to do physics with.
Yeah, I mean, I guess that'd be a question, David, is like, do you imagine this being a video that's 3D in which we have frames that we step through and we're never simulating, like, So the idea of having velocities is important if we want to simulate between time steps. But if this is just a video replay, so
Yep.
it reduces some of the analysis we could do,
Yeah.
but it means that you could have that slider on the bottom of the screen and slide to a current state in Unity,
Yep.
edit your window and move your camera and click
Yep,
an
all that.
object and see what its current position state is and all that.
Yeah. Yeah, and I do think we don't ever it's always bad when you get a bunch of smart people and you define the problem and then you try to find the perfect solution. So
Yeah.
we call it right out of the gate, like who cares about the perfect solution?
Yeah.
I think what we want is something reasonable in its reasonable in its accuracy, that we can see multi-second, probably let's say 5-second interaction clips that we could use for usability studies.
Yep. Let me call it.
Something's off by a couple pixels, or it's slightly delayed, or there's like some sort of little shift that happens where an object. And then I think the other thing that we can cheat on is that there's going to be some set of objects that need to be simulated or visualized very well. And there's going to be a whole bunch of objects that kind of don't matter. And I think the game designer, the game developer will be able to make that distinction and say like, hey, we're simulating like Autumn used the example of like a particle effect.
Particle effects, right?
Okay, so who cares?
Don't matter.
Like none of it matters. We've got some clouds over there, but then we've got other objects that you're like, oh, these are consequential in some way to anything we would ever care about. So I guess that like baseline assumption I've got for how to architect this would be right out of the gate, we would have some way to mark which objects are which category. Like these are consequential objects and these are not. And it might even be by class. So you want some way to mark those in the given engine. And then my assumption is we really kind of borrow from that video compression approach and effectively send iframes for those objects on a clock. So and I think that time scale could probably be pretty wide. Like I could imagine that it would work at the level of like every 5 seconds or something, like pretty wide. And that's when we would send a snapshot of all of those objects and we have to come up with some serializer, but it certainly transforms. And then any other, again, we've got to write a class that is the replayer class that is instantiated for every object, but it's effectively a serializer that we write on anything replayable. And then we use the deltas or the P frames as needed, but we actually run a simulation. So my thought is that we're doing a snapshot, simulate, snapshot, simulate. And that with our scrubber, requires a little bit of extra work of like grab the last iframe and then simulate forward. But we allow it to slip. We know it'll slip. But it'll be caught again every 5 seconds or whatever. And I think for anything we have planned and any kind of interaction we've ever made, that's going to work great. Like that's going to be plenty of resolution for the job we're trying to get done. Though it will likely result in objects glitching right on that line or little discrepancies.
Can I ask a quick question, David? So do you have an example? I don't know, use case isn't quite the right word, but like this example problem that you could imagine like this setup would allow us to tackle.
Yeah, it's the problem we're going to have in 2 weeks. So in 2 weeks, roughly, I got a great message from Ross on Slack. Is like, we can say we're gonna get something on the Meta store a certain day, but in reality, Meta has a voice in that. And
Meta,
way longer than you. Okay, so in a few weeks, we're gonna be releasing something in the Meta store that has had minimal user testing for all the reasons I've laid out. And in that, we're gonna have this new survey interaction that we've never done before, and we're gonna have hopefully an audience that's gonna be playing on this. I think what we want to do is full hands-off usability testing, where we're just watching data stream in, and we're having a designer review time, and we kind of handle it like it was a real playtest, where we put a session up on a screen, and we watch kids play it, and we observe emergent usability issues that we see. just by watching someone play it. And I think doing that is going to give us massive amounts of insights into what needs to change. Yeah. So that's the thing. Yeah.
So you could imagine, though, that the current approach we're doing, right? Like if the server just stored the actions the person makes,
Yep.
right? The actions, the random thing.
Yep.
Then we can generate local replays, both of a video file, but we could also generate the local Unity state.
Yep.
And you could do all of the stuff we're talking about, but do it offline and asynchronously.
Yep.
Fine. Right, because the other thing I got thinking about is like imagine weird local variables that you've got inside your class that are critical toward something.
The penguin moves into the attack mode.
Attack mode, right?
Yeah.
Exactly.
Yeah.
Right.
Yeah.
And so now we need the developer to make sure that they've flagged that. And if they don't, then all of a sudden all the, you've released this, you got a bunch of data logs and they're useless.
Yep. And again, the other requirement is minimal amount of extra work.
Right. So, I mean, part of me wonders, like, do we just try to keep the current, in terms of like from Luke's point of view, the stuff that's getting sent to the server, we're just going to send the random seed, the actions that people make, and we develop another tool that we're going to generate video replays, but we generate another tool that is like a Unity state machine.
Generator. Yeah. With huge amounts of like variables coming out of it if we want.
Right.
Like
but that's an offline.
It's
that's an offline process, and that's not the thing that you put on the App Store.
Yep.
That's just
That's also worth noticing is the asynchronous thing. Like we don't need to be able to look at these things live.
Right.
There's no need for that.
Right.
Someone played it yesterday, a month ago. Something could run. We don't need even a couple days. Like if there was some cute process that.
I mean, one of the things on my end that as soon as my grades get in, this is one of the things I really want to jump into is like to build a thing to go from those logs that we're generating that just is like a shell script that is just, you give it the log and it just runs that Unity thing and generates a replay for every single session.
Yep.
And then we can go through those.
Run it all the time, just a service.
Just run it all the time. And then we can go through those and we find weird sessions. Then we can go into the log and do subsequent analyses.
Exactly. Yep.
Yeah. But that to me, like that's on my end, I should have already done that. And it's like kind of there, but it's janky. I give me I think a week or two.
Yeah.
I can get that good. And again, we just have a computer that's all it does is sit there and generate replays.
And we can put that computer in the cloud somewhere if we want.
In the cloud somewhere, yeah.
So I think there's something really clever in that if we think of it as send minimal data from actual player client, okay, and then do something to make more data. I think that that's really cool. But I still think that there is some ground truthy thing that has to happen there, because if you only simulate input, things can go totally out of whack and you've got no way of knowing it.
So I think what we could do, because we do have events of when things actually happen in the game.
Yep.
When we replay it, we can check to make sure that those events happen at approximately the same point in time.
Okay.
Right?
Yeah, because we're getting the hand picked this thing up or this button was pressed.
Well, you push this button, right?
Yeah.
You switch to the next scene.
Yeah.
And if we're generating that replay for the video,
it should happen at the same time roughly.
If that doesn't happen, we can mark it and say something went wrong here. So I think we can catch. So we can't fix it when it goes wrong, but we can catch it when it goes wrong.
And know if it goes wrong. Yeah. So there's a little bit of kind of like a validation step you could imagine where we're like, we think this will work, we're going to run it, and then we're going to write this thing that evaluates if it worked. Like if all the events are happening all the same time, I think we can confidently say this is a good replay. And then for a given game, we can get a green light and trust it. And maybe for some other game, we get a red light and we're like, that didn't work. can't use this kind of replay in that game because something, and then we can go work on that when it happens. And odds are for the games that we're making, it seems like this is going to work well enough is the assumption.
Yeah, I mean, I've been surprised that because we're sending only 32 hertz, the
Yep.
telemetry data.
Yeah. It's like every other frame-ish.
It's like every other frame. And again, I don't think we should do that test I just said, right? Like we should
do
make
that
sure that these major events happen at the same time. But watching the videos that I'd seen, it seems like everything's working.
Yeah.
It it looks like
a video. It's amazing when we saw it the first time. It's like, wow.
yeah,
this
you know,
works.
like when the people get to the once we got the random thing, and again, haven't done rigorous testing, and we should,
Yeah.
but it looked like then all of a sudden people were getting to the end of the game, and all of the things they were looking at that were being generated all made sense, and
Yep.
But with that said, yeah, you can imagine we aren't capturing everything exactly at the level they did it.
Yeah.
And we have to hope. So did you say that the new stuff is multi-threaded?
Yeah.
Or maybe this is a Ross question. Is there a random being called in a thread?
There's probably a good chance there is.
Yeah.
Okay, then we're done.
There's a lot of, and so these later games have been more built on on Autumn's engine, and there's just a very large number of coroutines and
The coroutines aren't
things.
threads.
Yeah,
Yeah.
that's true. That's true.
Oh, that's a good point. Though better or
Actually,
worse,
maybe
Autumn gets into the details of like memory management and stuff.
Okay.
with-
Yeah,
So it gets
coroutines aren't
very
threads
dense.
though.
Yeah.
Coroutines
Right.
are on the same thread.
Uh-huh.
Yeah,
Yeah.
I don't know if we'd have to. Yeah, I think we'd have to check with Autumn in terms
Okay.
of
I mean, Unity
how
does not want you to
multi-threaded it
do
is.
multi-threaded stuff, and they make it
Usually,
tricky
yeah.
to do.
Yeah,
Yeah, usually
unless you're
they're
using
much-
like dots, then
Yeah.
everything's super multi-threaded, but
That being said,
The
I'm still thinking there's a good chance that there,
Okay.
there might be. But
Well, and what you can imagine with the coroutine is, right, if you have an asynchronous wait, so you asynchronously wait for a texture to load or something,
Uh-huh.
and now for different users, you have a different number of frames that have processed before that asynchronous wait happens. If random is going to return the same set of numbers every time, so are we using those same set of numbers in the same way every time is like the question. And if that breaks, then everything like what we could do is we could again try to, I don't know what the right word would be, find a solution to that, but that is where, David, I think your thing of like we need some kind of absolute thing that's coming every once in a while to make sure that we're not in somewhere we're not supposed to be.
you could log the random stream, and then your replayer, you just like
Yeah,
dependency inject your own randomizer that just replays the random stream rather than calling random again.
Yeah. Okay. So what if we added what if we never use Unity random directly, and we always wrap our random calls within a function that we control that calls Unity random eventually, but logs it?
so we just need to know what object that random, or what variable that random went to at what point in
Exactly.
time.
So we have some sort of, we just encapsulate any random call we do through our playback randomizer, and we architect it in such a way that we're always getting what we need logged and recorded along with the random number that was generated. So it would be, yeah, probably the object that's calling it, and then probably some like what it was calling it for that would be defined on the object again. So effectively any object that does random, that's when we would have to do some additional coding to make sure that we've made sure that
So here's the weird one. So imagine on my coroutine, I say, wait for an image to download.
Yeah.
So when the person played it, that waits a long time.
Yeah.
And in the meantime, random got called to say, switch background object's direction.
Yep.
But when we play it locally, the image is there and loads really fast.
Yep.
So,
Sequence
so
came
your
out.
random call hit earlier than it should have,
Huh.
and the other one hasn't hit yet.
Yep.
So imagine you're playing back the code. Like, what do you do at this point? Because you're like,
Yeah.
I mean, I guess what you do is you switch which number you get, but there's a
Mhm. Or are you assuming you have keyframes coming up every so often?
right now we're no keyframes.
Yeah.
So,
Right now there's
Yeah, no. But if you had them,
right.
then you just like, well, we're
Yep.
drifting, but we'll fix it in the next
Yeah.
keyframe.
Exactly.
So, because then that might be a way to think about handling your randomness, because then it's like, well, maybe you flipped the wrong coin, but it doesn't matter. You have the actual state of the
Yep.
world forever.
Yep.
And so random calls never actually matter for too long. And you would just have to, you probably, when you're running your actual like replay script and generating whatever new events or logs, you're probably reporting a percentage of drift as to whether or not you want to trust those event generations, but that you do in the replayer, not in the headset.
Yeah, I mean, I think that once we go to keyframes, this is just a very different architecture.
That's right. And it requires a ton of coding.
It
Because now
requires
every
a lot.
object needs to have a serializer class.
Mm-hmm.
I'm sure.
Mhm.
Okay, so just kind of playing with that a little bit. I like that we, without making any changes to the game, and who cares if it's multi-threaded and who cares how it's architected, we can run it right now, and we've got a way to measure if it's good, if the
Yeah,
replay
that's
is
true.
working, right? Like despite any of our
Yeah.
predictions, right? We look at the real data and be like, yeah, everything's hitting all at the same moment. So effectively, maybe it looked slightly different, but effectively the game state is
Right.
is this. So I like that. I like that a lot. And we do it with no coding, like zero coding. You just tell it where the camera rig is and it starts logging it, right? The next step up though would be, let's send a keyframe, not very often, that's very, very big, and snapshots, kind of like every object in the scene, just its transforms. So you just do a predictable level of inspection.
Or just its transforms and its rigid body if it has one.
Yeah, so some
something,
like
yeah.
some standard thing. It doesn't
Like
require
only
any coding.
pure built-in Unity things.
Right.
Yeah.
Yep. And so you imagine like, and so the replay would still be playing back the person's actions,
Yeah,
but at some fixed interval, everything might snap to its
That's
locate,
right.
right? So like
Just
somebody
fixes the
drops a
state.
screwdriver and it bounced to a different location.
Yep.
But 2 seconds later, it would go there. So hopefully when the
Hop
person
there.
goes to grab it, it's in the right spot.
Yeah, I think so. And that has the advantage of no extra coding as well. It has the advantage of like it catches anything that got missed in the first process. And then it has the disadvantage of that object. Let's say it's 100 objects with 6 degrees of freedom plus, I don't know what rigid body stuff looks like serialized, but that thing has to be sent some period of time. But I'm going to guess that some period of time is really long. Like I'm guessing we could even start with every 30 seconds or something.
Well, so the question is this okay? So is the goal of doing that to try to save a session in which the user actions didn't match?
Yeah. We only have to do it if the test of the user, if the
so the problem we have, so imagine like again in this game, made up game, I have a screwdriver and I drop it on the floor.
Yeah.
And in the person simulation, it bounces slightly differently than it does in our replay.
Yep.
And then I go and pick it up.
Yep.
So the interval in which it has to be reconciled is the time between I drop it on the floor and I pick it up. So that could be 30 seconds, that could be half a second.
It's dependent on the game.
Right.
And
now again, we can
the object within the game.
No, we can detect bad sessions.
Yep.
So what this does is it lets us maybe save some of those that in the past would have been just labeled
Bad.
What bad, right?
Junk. We don't know what happened. We just know
We
that
don't know what happened. Our
Yeah.
replay doesn't match up what they originally did.
Yeah.
We can detect that.
It also allows you to index into the replay without having to interpolate
Yep.
everything from.
Oh yeah, because
zero.
we can just hop to whatever the
Yep.
closest. Yeah.
Yep.
And then simulate from there forward, giving us Scribber.
Yep. Scrubber. And you can imagine you could almost do some kind of hilarious 3D video where you kind of watch the scene unfold at like, you know, it makes more sense if maybe it's every 10 seconds or something, but you could jump through in 3D. You could even be in VR and jump through and see how the scene like changes over time.
Yep.
More fun probably than useful.
Yeah. 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 10 minutes of hilarity and then
Yeah.
move on with our lives. I am really curious about all of this. I've got a feeling that almost all of the time for any games that we're ever going to make, if we can detect bad sessions, that's probably going to be enough.
I would say
going to work.
In some ways, the first step really is maybe to see how often bad sessions happen.
That's right. For a given game.
Yeah.
With no additional programming, no additional data.
Don't need to do anything else. Yeah.
And I'm guessing what that means is that we are effectively like noticing when a log event happens and making sure that one is logged in the file approximately the same time.
Approximately the same time.
We got some little window that we give it.
Exactly.
A quarter of a second or yeah. And let me think of how, so we build that obviously in Unity in the replayer and that's been the other thing that I've really liked about our current situation is the game is the replayer. It just has this extra module that loads a file.
Yep.
Feeds it into the right input system. So we would put it within that module that it would capture all the log events that the replayer would be sending out. And it would be looking for them in the file it's reading. Yeah. That should be not hard. And then it just flags it and sends a warning or an alert of they fall outside of that window.
Exactly.
And we're just going to get some number at the end. It's like how many times that happened.
How many times that happened?
Yeah. Where we want that number to be 0. And then we're like, we can fully trust this thing.
Yep.
So that's step 1. We should build that thing. That's really cool.
Yep.
And the cool thing about that then is we stay in the offline mode. There's no extra data traffic or load for the client at all. And we don't have to do anything that we're not already doing. It's all
correct.
Yeah. And then I think, let's try that for a couple games. And it's really possible that it's just always going to work.
Or works enough that we're okay with whatever the loss is.
That's right. It's not worth doing anymore.
Yeah.
Like 5% of sessions, we don't know what happened. So be it.
Well, there'd be value in looking at patterns for those 5% of sessions. Like, can we fix that? Can we?
Yeah, that's a great point.
Yeah, that is a great point. And it might just be that we need like a couple extra telemetry events or something, or there's some other little more localized fix that doesn't involve state snapshots, which is obviously the sledgehammer kind of approach to this still. Yeah.
Well, I think it's also if your sessions get really long, I mean, VR is going to kind of inherently shrink them. But if somebody spends like an hour in VR and you're reinterpolating a full hour every time.
Yeah. Oh yeah, that's what it doesn't give us is Scrubber.
The indexing, yeah.
This still requires us to do some sort of processing.
If you trust them enough, you could generate the keyframes as a post process.
Yeah, exactly. As I say.
Yeah.
We could do it in post, so we don't necessarily need to do anything from the game side of things.
Yeah.
That might be worth. It might be worth trying to set up the actual keyframer once, so you can empirically test drift.
Yeah.
In doing it in post, but
that's a good point too. Okay, so that leads us down a different path a little bit, which is let's let's not build the thing that looks at telemetry events and compares them to what it just generated and see if they're happening within a window. We could set that plan aside and instead do the brute force log serialized version of basically every object offline and create a new log from that. We like log that big horrible object locally somewhere, and then rerun the simulation 5 times locally using the same input and see if it ever changes. And if
I've done a
that
bit
big
of that.
object ever changes, then we know there's some drift that's being caused by something.
I've done a bit of that in my own game, and I think you'd probably want to be doing this like on a game by game basis. But in my own game, I didn't have any drift, even running the simulation at like 20x speed and like rigid body bouncing interactions and stuff. So granted, I was my keyframes were I actually don't know the average, but probably on average like a second or two away from each other. So like only
Yeah,
so
it's
much
real.
can happen in that much.
Okay, so just to capture it, that innovation of today, I think, is a validator and thinking about building a validator. That's the new idea, not a logging system. And then it seems like we've got at least 2 ways to do it. One of them compares events, telemetry events to generated events during replay. And if that works, then we can do all sorts of stuff offline. We can generate whatever logs we want that allow us to then go into a replayer to scrub it or whatever. And it can be large amounts of data it generates. But large again offline is like it's on your laptop. You load a session, you hit go, and it like generates all the stuff you need in a split second before opening it up, and you can scrub it and do whatever you want. It's all in RAM. And then the other approach was offline generate a state snapshot using serialized versions, no coding of all the objects in the hierarchy, and just run it a handful of times and see if they ever drift from each other, indicating that the game has some sort of drifty bit. And if it doesn't, then you've generated your snapshotty thing that you can use in a scrubber.
And that would also let you know how big that snapshot's going to be.
That's right. Using a brute force, we're local, we've got RAM. Who cares if it's 10 gigs for one session?
It takes forever to write to disk or whatever.
Yeah. And forever in this case is still going to be like 2 seconds because it's in RAM. It's not going over the internet. And it's not running on a Quest device. It's running actually, that might be the problem with that approach, or it could be the problem, is that a Quest device is going to be susceptible to all sorts of weird stuff. Some background process ran, it's really slow, it lagged on a frame, where your desktop computer is going to just inherently be a different thing. It might be like more reliable. Hence, we still need that first approach of checking the telemetry that was actually generated. And okay, I think plan 1 is the way to go. We create a telemetry validator tool that sits inside of that.
Yeah.
So the only question I've got there then is how do we, I guess we change the open game data logger object to point at our replayer validator and send any events that would be going off to open game data over to that thing as they're created instead of sending it to open game data, which actually, like there's that little bit of code anyway that we have to say, like, don't send replay data into the server. Like we had that problem. But we send those events over to the validator tool instead. That's reading the file.
So are you thinking that the server would do the validation?
No.
Okay.
So we download we've got a file.
We download the log file, right? From the log file, we generate a session file. And that session file would have the telemetry data and then would have these other events.
Yep.
And as we replay, yeah, I see what you're saying, right? Then what we want is that we want the local Unity thing. This would be on like Ross's end.
Yep.
So if I'm running on a desktop computer, right, we don't want it to send these events to a server.
Yeah, we don't want it to go out to the actual log system.
We don't want to go to open game data server already because we're
Yeah.
just going to be duplicating our process.
Yeah.
But we do want to create some kind of callback or something.
Yep. That shoots it over to the thing that says, okay, the event is in the file, and here it just came in from the rest of the game.
Yeah.
And it happened within a window. That's going to happen in, I'm calling it the validator right now.
Yeah.
And it's
So
the
it could
thing that's
be
reading the file.
Yeah, and it could be even as opposed to sending it on the network, it just dumps to a local log file.
Yeah. Yeah. And I think the assumption is if we do that validator stage, there's a good chance it's just going to work.
Mm-hmm.
And then we don't
That's the
need to do
hope,
anything
yeah.
else. And if it doesn't work, we know that the backup is that we come up with some some state serializer function that we send at some given interval.
Yeah.
But if we don't have to do
So-
that now, let's not do it now because
Yeah.
we don't have to. We can prove that it just works.
So so Ross, right now is the logging like wrapped around to like an if not editor define or something like that?
Yeah, there's a flag to be able to set to prevent that.
That basically when if you're running the editor, it
Running
doesn't.
editor, it doesn't send a open game. I think
Does-
for early on for a period of time, I think it accidentally was.
It was, yeah. I remember we fixed that. So right now is it not sending it, or is like the log object not being created?
That's a good question. I think it's just not sending it.
Okay.
Yeah. Although, yeah, no, that's the case. Yep. The
Okay.
class still exists and it just
Mhm.
ignores sending the information.
So what we'd almost want to do is like have that flag. If you're not going to send it, then say like, do you have a local file,
Mhm.
Mhm.
and just write to that file as opposed to sending it to the network, or point it to a different network address, or
Mhm.
Yeah. Because those will, yeah, if we did it locally, I mean, the bummer there a little bit is that it would drop onto the quest locally, which is kind of a pain to grab. But
No,
it
no,
is possible, but
This should be
we
running on-
we don't want this is like if you're running in the editor.
Yeah.
oh, okay, got it.
So,
This
so
is
if you're
only for
running the
this
editor,
offline testing.
imagine you
Got it.
have a variable you can set to be like a local file path or something.
Yep.
That if you set that variable, then if we're not sending it to open game data, if you have a
Oh,
local
got it.
file path,
Okay.
then you just write to that local file path.
Gosh,
Yeah.
instead of even writing to disk or anything, though,
That's-
it still
yeah,
seems
that
like
works.
it seems like if you just do like a stack object that you're
Mhm.
just putting all your logs into some, a stack object, and then you've got the file reader that's looking at the log file that has all those telemetry events.
Yep.
It's just popping them off the stack if the timecode matches since launch close enough. And
Mhm.
you're just clearing it out as fast as they're going in.
Yep.
And you're not
Yeah,
even going to disk. You're just going right into some.
Yeah, I don't. Yeah, is there like an event object or something like that, Ross? That you could just store in a list or
At the moment,
like David said, stack,
Yeah, a list.
a
at the
stack
moment,
something.
there's
First
not,
in,
I
first
mean,
out. I don't know.
we've got there's a logger class that handles all of the sending. So I mean, I would think that we would want to, yeah, just put it in there. And so
Okay.
that, like whenever there's a call that would be doing a log, we just grab from whatever the current
Yeah.
list point is and
Yeah.
there's it at that point.
The one thing with that, David, that I was just thinking about is that if you have a list or a stack and you're not popping them off, and
Yeah.
imagine you have an hour-long session,
Yeah.
if it's starting to like build up.
Well, you already failed the test though at that point.
Well, so imagine that you didn't implement the replay object that's popping them off.
Oh, well, it'd have to happen in the replay object where they would be stored. It's in the replayer tool code,
Right.
say. That
But
you're
but if it's in the, so we're saying that we need to modify the code that sends to the server.
Yeah, we modify the open game data logger object
Yep.
to say, go into this other mode where you send the events to this local object that's running.
Oh, I see. So,
And it's probably just the event name. It probably doesn't even need event details. It's just like
Got
having
it.
the name is
I see
probably
what you're
enough.
saying.
Yeah.
So what you're saying is that the logger would get a game object or whatever, a class that is the replay class. And
That's
if it
right.
has that, then it pushes it. Oh, yeah, that's a good way to do it. I like that.
Yeah. No files. It's just, and yeah, if that thing starts stacking up, then that's your fail.
That's your problem then. Got it.
You know that it's a problem. And the other thing that's interesting about that, I guess, just kind of think about optimizing it even, is you don't, I guess you could just check every event. So you could have every event go into the replayer when you pre-process it. But I'm also guessing that you don't need every event. You could have some subset of events that you bother to pass into the replayer.
Although, why not let the replayer decide?
Yeah, that's true. Like just give, because what it means is you're going to go up to Open Game Data, you're going to grab your file. Then you're going to run your pre-process that pulls out one session, and you're going to let all the one session feed into the replay file that you open up in Unity. And it'll just compare everything that it's generating to everything that was logged, and it's going to tell you if it matches or not.
Yeah. I mean, in the meantime, what I was planning on doing is when I take the log file and generate my little replay file, that I would then create basically a dictionary of all of the events.
Yeah.
And then when I replay it, I would have that dictionary to compare against.
That's great.
So we could also do this without Ross having to do anything.
That's the goal still too, is like game engineers are busy people.
Yeah.
Let's let data people figure this thing out to make their lives simple.
So like, I guess I'd say like theoretically the log file already has all of this.
Yep.
So we actually don't need to do anything. It may be more convenient to do it the other way.
We don't need to modify anything in the game at this point. We will roll out and commit this change back to the Open Game Data logger, but we can have a local version of it now, that
correct.
That does the job. It'll just have some code that will push out to the Quest that's disabled during run. But
you could flag it behind a custom processor directive for being in replayer.
There you go. Yeah,
that's what I did.
Yeah, that totally makes sense. Cool. I'm like thrilled with this step, and I'm hopeful it's going to work. And it won't work always, and we know that, but it will work enough, I bet.
So David, the meeting on Monday that you scheduled, is that the same?
Yep. So we can cancel that and use it as work time, or we could, I mean, I guess we got to figure out who's going to implement this thing. Because it's going to be a change to the replayer and a change to the logger objects. That'll do this whole stack thing and send the events somewhere else, and do these events line up with the file. So we got to figure out who's going to do that, and I assume that's going to be Autumn or Ross.
So I was assuming this is going to be me.
Yeah. Okay. So I was going to say you obviously are in there as well, and probably.
Yeah. So I would say like we could either put that on Autumn or Ross, or I mean, if we gave me like a week or two, I think I could probably also do this.
That's the pressure we've got, is we want this to be ready when we put it out on the App Store. But luckily it doesn't.
But at the moment we're saying we don't change anything.
Yeah, that's true. It doesn't have to be. We only want it ready so we can test as soon as data starts coming in.
Right.
Yeah.
So that's a weird thing, is like in some ways if this test starts to fail a lot, then it says we have to restructure this. But the problem is the restructuring, I think, is not a week or two thing. It's a longer.
Yeah. It starts with do some sort of gross snapshot of just everything serialized. And then we optimize from there, basically.
So another thing we could imagine, although I don't know, it feels like equally hard, would be that we have a flag that tells the server whether this is a replay or not.
Yeah.
And then just kind of compare the two logs. So we could do it like in you're not, are you using SQL or not using SQL, Luke?
We're using SQL, but that logger is a busy beast.
Yeah,
and be able to process this thing.
I don't like that solution either.
Okay, good. I'm like, I
I-
see why that's an interesting spot to do it, but it has the problem of like, we use
feels
that
like just
logger for not research. We use it for like, it does one thing. It writes stuff to SQL really fast.
right,
And we never even read from the SQL.
right.
We're like trying to keep that thing humming. Just all writes, no reads. At night, it reads from them and puts them up on another server. So that's a weird place to do it. Yeah, we're just building like a local capture thing. That's cool. So we could use that meeting to like really architect the objects and stuff. But I assume at this point, like you just go. Like we've got the rough plan.
Yeah, this is something I've been wanting to do anyway.
Yeah.
This has like been on my to-do list. So
Yeah.
like I said, my grades are due Monday, so it's gonna be just a crazy push until then.
Yeah.
But after that, then things calm down a bit for me, and then like the week after that, things really calm down. I can really just
Great.
jump into this type of
It
stuff.
sounds fun. It sounds like the stuff we signed up to do when we
Yeah,
came out.
yeah, exactly.
All the paperwork. I love it. I was thinking of, I'll show you my little tinkery thing. Every once in a while, I'm like, wait, I have like a background in computer science. I know how to make things. This is iteration 2. So it's like a pan tilt server system with like belts.
Yeah.
And it's for my garden protectron that I'm building. So
Uh-huh.
I've already got iteration 1 that I've tested in the yard. And it's a pan tilt with an infrared camera that runs OpenCV, and then a solenoid that controls a high pressure water hose.
I've been thinking about doing this.
Really? Okay, so I built one.
Nice.
Got the 3D
Nice.
models if you want it, and the parts. But it was all based on servos. So
Uh-huh.
even though they're girthy servos, the amount of recoil from the water is going to eventually blow them apart. Like
Oh, really? Okay.
it did work, and it's absolute hilarious to do because you can sit inside or on your phone and you can like target the bunnies, chewing on your seedlings, and there's like a machine gun mode where it's pulsing it. And it's just great to watch the pulses fly out. It's like, doo, 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 doo. But it's going to fall apart. So I built this like girthier one that uses these big steppers now last night. And I'm really excited to get the AI version of it running where it's like a full-on sentry that's tracking where motion happened, moving to that location, adjusting for the ballistics of the water based on where it's at in its up-down movement and a calibration.
You should sell these things.
Yeah, and then you get to
But-
monitor it too, so
but-
it can send like kill cam in where it's like,
Yeah.
here's the 5 seconds before and after of me doing my job.
We'll grab a bunch
Yeah.
of images of rabbits and squirrels and stuff from the web
Yeah.
and train your object detector.
Yeah, like doesn't it? Well, I don't even think we have to detect objects. I think, at least for my yard, anything that moves gets shot. And again, by shot, it's like the super nonviolent of doing this, like to squirt them and just train them that this yard is not for them. So I'm trying to get it ready by, I guess, next weekend when we're going to plant everything.
Then sometime in August, it's going to get real hot and the squirrels are going to figure out how to make it.
Yeah, like use it so they're just standing with their mouth open. I put a version of it online and put it on the field day Slack last weekend and let people drive it from just anywhere on the internet. It's I don't know. Again, I've got this background and I don't get to use it very often when I'm doing proposal writing and spreadsheets. So it's kind of nice. Build some stuff here and there. Okay, thank you. I think that was really successful. I love it when we have to come up with solutions that weren't where I started.
Well, thank you for getting this all together, Dave.
Yeah. And yeah, if you ever want to hang out on these calls, yeah, we just do some sort of office hours related to game data with different researchers from around the country every other week.
Okay, yeah. So if you're talking like 2 weeks from now with the next one of these?
Yeah.
Okay. So
we might send around like we might contemplate changing the time for the summer, but
the summers, yeah.
I'll circulate a poll on the Slack.
Yeah. Because I'll try to have something for us then to look at 2 weeks from now. Does that work?
Yeah, we've got a couple other topics for the yes. Okay, but this meeting 2 weeks from now may or may not be that. We've also got we've got something in the queue to work on our first Open Game Data 1.0 data standard.
Nice.
We've got some working meeting around that where there's a whole bunch of projects that are happening that we're hoping implement this thing, so they're going to be compatible.
Yeah, so we could have a different meeting than
Yeah,
this
we'll have a
one,
different
yeah.
meeting for that, but we can use this meeting to come and report back when we've got something like that's almost a paper
Yeah,
phase. This meeting is really helpful for that. We have almost a
perfect.
paper, or we've got a paper and we want to like just talk it through and see how people are vibing with it.
Yep.
Okay,
Alright.
cool. I gotta go. I will see you
Yep.
around.
Yeah, sounds good. See you later.
Thank you.
Yeah.
All right.